The halogenation reaction is an addition of a dihalide to an alkene. Now, typically this reaction works well for bromine as well as chlorine, but typically we don't use this reaction for iodine or fluorine. In many cases, fluorine is way too reactive and is difficult to control. And oftentimes iodine is not reactive enough and won't react with the alkene. But the net result of this reaction is that we add halogens, one to each carbon of the alkene. In addition to that, we get what's known as an anti-addition of the halogen. That anti-addition means that they add on opposite sides. So why do we get an anti-addition for alkene halogenation here? Well, we can see some of this within the mechanism. So the mechanism for this reaction is that the alkene attacks one of the bromines, which in turn attacks back to the alkene and kicks out the other halogen. So what we form is a three-membered ring known as a bromonium ion, along with a bromide ion. It's at this point that we can see where we get the anti-addition from. If you think about the shape of a six-membered ring, and I used a ring here as the example because it's easier to illustrate, that bromine, say it's on the top side of the ring, is going to have to be only on the top. It's not going to be able to bond up from the ring on one side and down from the ring on the next carbon. It just won't work that way. And so when the second bromine wants to attack, the only place that is available for it to attack is from the opposite side of where the first bromine is. So if that bromonium ion or the first bromine is on top, then the second bromine, when it attacks and opens the ring, will have to come from the bottom. And so as a result, in this reaction, we get the addition of two bromines, or if we're using chlorine, two chlorines, and they come from opposite sides. And that'll happen regardless of what the alkene is. In a case like this one, we don't really notice it because the alkene is at the end of a chain. But regardless, those two bromines will add on opposite sides. And we can see the same thing in this final example here with chlorine. Again, the two chlorines, just like the bromines, will add on opposite sides of the molecule.